In this video, I'm going to demonstrate one way that we could use a technique known as parallel arrays to keep track of lots of different objects on our screen in terms of their size, their position, and just their state in general. And so I've made a little sketch here where if I click, it adds some little bubbles, and each of those bubbles floats to the surface. You'll notice the bigger bubbles move a little faster and wiggle a little more side to side, then the smaller bubbles take a little bit longer. The sound is just kind of for fun there, but you'll see right now I've got all these moving shapes. The background is being redrawn frame after frame. That's why we don't see, a trail of where all the circles were before. But yet we've got a variable number of shapes. It's not like I have a bubble 1x and a bubble 2x and a bubble 3y that I've created individual variables for. This is one of the places where arrays can be really useful. But of course, we haven't learned about how to use objects yet, and so what is the thing I actually put in the array? Well, we're going to keep track of the x coordinate of each bubble, the y for each bubble, the size for each bubble, and then the sound we won't put in that's just kind of for fun. But that's going to allow us to have an arbitrary number of bubbles involved in our sketch, while keeping everything neat and tidy so our bubbles, have a known location and size at all times. So there's one more demo of it. Let's go ahead and create a new sketch to get started. So to make this, we're going to want, just like we might want in many other examples that use parallel arrays, we're going to use one array that keeps track of the x value for every object. So we'll call that x's, and we'll create an empty array just like that. I'm going to zoom in a little bit to make this easier to see. We'll do the same thing for keeping track of our y coordinates, and we're going to let every bubble also have a size. So we'll create an array called sizes. So the key concept here is going to be that these arrays must always have the same length, because the index within the array is how we're going to coordinate the x value and the y value and the size for a given bubble. So let's go and put some numbers in here. We'll start with really simple numbers. So right now, this would indicate having a bubble at the x, y value. Let's make these clearer. 1, 2, It has an x value of 1, a y value of 2, and a size of 3. I could add some more numbers to these arrays by hand for the sake of example. So now, in addition to the bubble who's centered at 1, 2 with size 3, I also have a bubble who's centered at 4 in the x, 5 in the y, with a size of 6. So these represent two different bubbles. It might be useful to look at them sort of on top of each other. I've got three arrays, all with the same length, where the value stored at index 0 of all these arrays tells me what I want to know about my first bubble. This tells me what I want to know about a second bubble. So this is the reason we call these parallel arrays, You can sort of see these parallel lines of data forming. And of course, we can add arbitrarily to these. We just need to make sure that they grow in length at the same rate as one another, so we always have the same number of x values as we do y values as we do size, since every bubble needs one of each. So I'm going to expand my canvas just slightly. We'll change our background to blue to make it feel more like water. Let's see, is there an aqua? Oh, that's nice. Okay. So for the draw function, we're going to have to loop over these arrays and draw all of our bubbles. So we're going to want to loop over our arrays just like we've done before. So we're going to start with an index of 0, and then it might seem weird to use x's dot length, but remember, x's dot length is always going to be the same as y's dot length, which is always the same as sizes dot length, as long as we do our job right when we're programming. So we could use x's dot length, or we could use y's, or we could use sizes. It doesn't matter. They're all going to have the same length. But this is going to create a for loop that loops over these parallel arrays and allows us to grab a given value from that array. So let's go ahead and use the mouse pressed function just to add a bubble every time we click. Okay, so when we press the mouse, we're going to use the push method to add our mouse x to our list of x's, So we're going to say x values dot push wherever my mouse was. Similarly, we'll say y's dot push wherever my mouse was in the y direction. and then we'll pick a random size. So we might say sizes.push, and this is the moment of creation for this bubble where we're going to choose its permanent size. So we might say, give me a random number between, I don't know, 15 and 60. So every time I click my mouse, all three of my parallel arrays, in this case, get updated. They get a new X value, this one gets a new Y value, and sizes gets a new randomly generated size. So if we go back into this for loop, we can go through, remember we're looping through all three parallel arrays at once, and we could say something like, let X equal X's at I. We're going to go into the X's array and grab this particular X value. We'll do the same for Y's, so we're going to go into the array of Y values and grab just one of them out, and we'll make our diameter a value we pull out of sizes, right? We would normally call that size, but that's a reserved word or a predefined function in P5. So now from these parallel arrays, which might have any number of elements, we're grabbing one X, one Y, one diameter. These are the three attributes that define one bubble. And so we should then be able to say, draw a circle at that X, Y, and diameter. We want to fill our circle with white. Let's turn this back to blue. And let's say no stroke for anything in this canvas. We don't need outlines. So if I click, you'll notice everywhere I click, I have a bubble. This doesn't look that exciting yet. Of course, we haven't added motion, and even without motion, right? Clicking and adding something to the screen is something we've done many times by just moving this background function up to setup, right? So far we haven't quite seen the benefits of using these parallel arrays, but you can see if we were to go through at the end of each draw function and just say print out X's and print out my Y's, Y's, we can go ahead and see a list, right? You'll see we have a circle whose X value is 190 and whose Y value is 203. If I click up near 0, 0, you'll see now I also have an X value of 26 and a Y value of 22, right? So every time I click, you'll notice each of these two arrays, maybe it is easier to see if we label them. Let's say X's, and we'll do the same for Y's. Okay. Right now my X's just has the coordinate 127 in it. My Y's has 144. If I come basically directly to the right where we're increasing X without changing Y much, you'll see now I have a big X value and a similar Y value for my second circle. We could do the same for size if we wanted. Every time I click, notice that both arrays get longer by one entry. Okay, so X's and Y's are adding the coordinates for these little bubbles as time goes on. That's good stuff. So in order to really see the benefit of this, we want our little bubbles to move. So already, right, we're going through and grabbing our X, Y, and size for each of our bubbles and drawing it. But if we want them to move, we need something about our X and Y value to change. And so what we might do is say we want to determine some variable, we'll call it speed or velocity because speed is reserved. We're going to pick a random number between negative, let's say, oh wait, the speed is just going to be based on the size. So let's say it's, a tenth of the diameter is going to be our speed. So this variable just tells us, bigger bubbles are going to move faster than small bubbles. Okay. If we want to actually change, we need to change our Y coordinate. And so we might say our Y is going to get smaller since we're going up towards 0 by that velocity. But changing Y here, if I run this code, you'll see doesn't have any effect. Our bubbles still don't move. Well, that's because this Y is just a temporary variable that exists for this iteration of the loop. What I really want to change is the contents of my parallel arrays. So instead of changing Y, I'm going to change Y's at I. That actually changed the stored value within these arrays so that our bubble will be drawn in a new position every time we loop over the array. So if I click once, you'll see the bubble moves upward. Okay. If I click multiple times, each of them you'll see moves at their own speed, which is determined based on their diameter. That's just a cheap way of making our bigger bubbles move faster. This is pretty good. If you go back to the original sketch, you'll notice my bubbles were kind of wiggling from side to side. And that means we're going to have to make some change to the x value of each bubble. Right? So we need to put something here. The way I did that was I just chose a random number between maybe -3 and 3, and now every frame my bubble is going to either move a little bit to the left or a little bit to the right at random, and we get this kind of motion.